centric topic. We rotated between native, web, back end, front end, things like that. So really great, and glad to have you. So thank you, Rakesh. Oh. Don't touch anything. Right. Let's try that again. You said that on the line. Audio check.
You know, I think someone may have unmuted on this side.
Oh, it was a head cack.
Ryan, you sound good on the call.
Awesome. All right, everyone. Well, let's give Rakesh a round of applause.
Thank you. How's everybody doing? Good. All right, with the show of hands, how many non-Weedmaps people do we have here? Nice. All right, so there won't be too many people drilling me. All right, great to have you guys here. Hope you guys enjoyed. Let me just go in and start a little bit about who I am. Rakesh Patel. I think my title is Senior Systems Engineer. I have really no idea. I just like to be the guy who codes. I have a 20-year career on the internet. Worked at GeoCities, which eventually got acquired by Yahoo. Worked at MP3.com, eventually got acquired by Universal Music Group. Worked at Napster, eventually got acquired by Best Buy. So I've seen a lot within the internet space. Been through a lot. Covered every aspect. I've been in data engineering. Worked in backend systems, built APIs. Worked in infrastructure. Even built recommendation systems. So I've seen the whole gamut when it comes to technology and kind of engineering organizations. We're talking about evolution. This is kind of my evolution in coding. I initially started out with Perl. MP3.com was a big mod Perl shop, Apache mod Perl. We served 80 million users using a site built on Apache mod Perl, serving MP3s. Then got into Java, Ruby, JavaScript, Node, and my latest kind of passion is Golang. So I've been getting really into Golang lately. It's a very ops-oriented language, so it's very like we in the ops world love like Golang because of things we can do with it. Any questions? All right, let's get started. All right, talking about the evolution of infrastructure. We in the DevOps world, we like to talk about journeys. Journeys are important in the DevOps world. If one of the core principles of DevOps is constant feedback loops. You always have a constant feedback loop. You look at something, you evaluate it and see how you can change to create to make it better. Journeys are a way to go back and kind of look at how we did on those feedback loops. Kind of like see what our journey was. What did we see? What did we change? How do we adjust to it? And what happened? So hopefully you guys like that. It's also a little bit of a hippie in me, right? I like to reflect a little bit and meditate. So hopefully you guys enjoy this as we go through the journey of infrastructure as code. So how did it all start? Manual. Yeah, rack and stack servers. You get a pile of servers, you image the servers, you go to the colo data center, rack them up, wire them up. That was how you did it, right? It's just putting up servers. Usually what happens is your fresh companies would put their database, their API server, everything on one instance. You get that. That's just how it worked. Probably about the only thing you probably did when you're deploying code, you probably just have to say change to the box, SXP into things. Maybe you got a little fancy, you have some distributor rsync or something like that you wrote, but that's about the automation that you got there. Then we got basic automation, right? So you got things like CF Engine, people got good at writing bash scripts. Perl was really big in the initial in automation. People use Perl scripts to automate a lot of things. MP3.com, we created a distributor rsync to distribute our code to hundreds of servers. You create agents to register each of our instances so we know what instances are out there. So people hack together a lot of things to be able to kind of automate those things. It wasn't really a big flourish. CF Engine probably was the biggest tool I've seen out there. Be able to automate configuration. You update configuration somewhere, and all of a sudden configuration is updated on your nodes. That's about what we get. I get a little nostalgic though about the distributor rsync. I remember at MP3.com, it was kind of cool because when we worked there, it's like anytime you wanted to build something, they go, okay, how many servers you need? All of a sudden, you walk in the office, there's pizza boxes, just servers sitting there getting ready to be imaged and racked, and then all of a sudden people writing these codes and tools, Perl. We were at MP3.com, we originally did a lot of DevOps stuff before DevOps existed, which was really cool. Then we got machine virtualization. All right, now shit's hitting the fan, right? You can conceptualize the entire instance of the machine through software now. Now you can bring up an instance of the machine through software. So people are locally, you can bring up, you have a Linux server here, you have a Windows box here, and you got all these virtual machines on your box, you can do all these things with it. So we're getting better at it. You have software to drive it. Eventually, outside of, Vagrant probably came later on, but Vagrant was a really big tool. I don't know how many devs I would say back in the day, but Vagrant up, right? Vagrant up is how you bring up your dev environment. So machine virtualization is really big. A lot of big companies got good at machine virtualization. They started creating rich APIs around putting up machines and that sort of thing. You also have not only machine virtualization, you have network virtualization. It's easy to program routers and create segments within your router groups. You can call APIs. So all that's starting to happen. And this is where things happen. Is the commoditization of infrastructure. Amazon got really good. They created dev infrastructure with machine virtualizations for their entire dev shop, right? Amazon, they got really good. They said, hey, we're really good at this. Let's start renting this stuff out. They created rich APIs. All these companies create these rich APIs where you can, within an API, put up a VPC, put up a network instance, put up security groups, do network policy, put up an instance, you have load balancers, everything through an API. You can put things up. So as a result, we increased our capability, but complexity increased, right? So once we increase our capability of doing things, we have all this complexity we got to manage. Initially, you're probably managing this stuff with the AWS CLI, maybe Bash, maybe write some Python to hit the API and that sort of thing. But what eventually emerged is this tool called Terraform. So Terraform represented all your infrastructure as configuration files. Now you can represent your entire infrastructure as a configuration file. Spin it up, bring it down, whatever you want, stamp it out as many places as you want. And so with capability came complexity. And so managing complexity with increased capabilities was the biggest thing that came out of this. So with this complexity, this is what now a simple web architecture looks like. You have your user here. You have CloudFront, maybe CloudFront hitting an S3 bucket with some assets. It hits a load balancer, you got your front-end server group. The front-end server group is hitting your API server group that has a master and a replica database. Now this is all configuration that you have to put in code now, right? So you manage this, and imagine that you have a few services that have the same sort of thing. That complexity increases at that point. So managing this complexity is really difficult, and that's where tools like Terraform emerge. So this is how we started out when commodity legacy ops. So I'm gonna give you a little background. When Weedmaps first started bringing their ops team, we had initially outsourced ops to a third-party vendor, and we know how that goes with outsourcing things to third-party vendors. Ownership usually winds up with the vendor, and it never comes back to the person outsourcing, right? But so we wound up having this sort of infrastructure. Basically, our core API, of course, was handled by Ansible. Ansible. So Ansible is a configuration management tool. You can work with AWS. You can work with instances, that sort of thing. And it was built around a homegrown API. So the way it worked was a user would check in, check in something to Git, would hit Ansible API, and bring in the Ansible configuration from GitHub and apply it to Amazon. We also had an AWS OpsWorks. So there are some applications out there that use AWS OpsWorks. And then at the other end, we had people that's why I made it really big. They were just hitting Amazon directly. So there are things people are creating just in Amazon through the UI, point and click. That's repeatable, right? So that's kind of state we're in at that point. So I'm gonna go narrow it on deployments. So one thing we were doing that was kind of neat were initial blue-green deployments. So even though that infrastructure was kind of out there, we had blue-green deployments in place. So how'd that work, right? So you check in your code to GitHub. Am I in the way? Here, I'll do this one. You check in your code to GitHub. You hit the Ansible API. Say, okay, I want to do a release. Ansible says, okay, build an AMI. Who doesn't know what an AMI is? An AMI is what they call an Amazon machine image. So it's a representation of the virtual machine. So you build an AMI and you store it in Amazon, and that's the image. Basically, I think of it as your ISO, or basically, right? So you build your AMI, right? Once that AMI is built, Ansible then will hit AWS, build a new autoscaling group with that AMI, then replace it in the load balancer. So it's sort of a blue-green deployment type of thing. It's slick. It's kind of, I remember I built my first CD adventure. It sounds neat on paper, but the biggest thing is building AMI sucks. I don't know if you guys have seen this one, you know, #1 programmer is excused, right? The new one's now my AMI, right? Let's see, let me try to tell you this. So the way we built our AMIs is we have a golden image, right? So the golden image, we build on a nightly basis. That's with all the base software and everything within our image. That's basically whatever we put in the golden image. Then when we do, which that was taking about 45 minutes, I want to say, but it took a good amount of time. To me, above 15 minutes is too long. Right, I think above 15 minutes, even now it's less. But it's about 45 minutes. Then with that golden image, what you do is every time you want to deploy, you take that image and now you install your software, possibly update more software that's on the image itself. So that's probably another 20, 30-minute build just in the deployment process. So at that point, once it's built, now you have to put it into the autoscaling group, spin up instances. So you're not spinning up. So to spin up a machine takes about a couple minutes, 3-4 minutes. So now your deploy pipeline is taking about 2 hours. That doesn't sound very good for continuous delivery. So that's a really hard part. And then the other thing is, what happens if your build fails at the second hour? That's the worst day ever. You know, it's like when your builds fail at the end, it's like you just wasted about 2 hours of your life just watching your build trying to finish. You know, so AMIs did not seem to be a good method for delivery in a continuous delivery environment. The other thing, the reason we want to deliver fast, I'm gonna get a little bit into the reason we want to deliver software fast. At the end of the day, when you think about it, the cannabis industry is very fledgling. We're still a fledgling company, and we're trying out things, right? And so we want to empower the software development group to be able to try out things, right? And the only way we can try out things is if we can deliver software quick and also deliver updates quick, right? So if we put something out there and it breaks, we want to fix that as fast as possible. We want to deliver the updates as quick as possible as well. So quick software delivery is very much a cornerstone of how we're trying to build what we're building. The other thing is, where's the truth? You know, you had that big line that's going where people are just updating your AWS account and that sort of thing. Where's the truth? To be honest, you know, you can't have the truth. We probably couldn't, right? we probably see some big security gaps. We probably wouldn't like to see the story that we would have saw if we were looking at that. Do we rely on documentation? I don't know. You know how old documentation gets. You know how well documentation gets updated, right? So the documentation is probably not the best in that thing. And especially also when we're doing manual things like that, it's hard to do cost analysis because we don't have an inventory of what's out there at that point. We could write a script to do some API some queries and that sort of thing, but we really don't have an inventory of what's in our infrastructure. So we need to maintain somewhere where we can keep the truth. So what do we want? So what we decided is we want to make sure that our infrastructure is version controlled. GitHub is awesome in the sense that you have an audit trail, you got peer review process built in. You see every change that's going through. So if we can get our infrastructure into version control, we have a great audit trail. We can figure out everything that's happening. So one of our main goals is that we want to make sure that infrastructure is version controlled. It's a single source of truth. Infrastructure is repeatable. We want to stamp out things. We want to rebuild, rebuild things. We don't want to point and click, okay, let me put up a load balancer, all right? Let me put up an EC, like the auto scaling group. We want things repeatable. We want to stamp them out really quickly. If a group says, I want an RDS server, we should be able to change a few lines of code, and all of a sudden they have an RDS server in about an hour. We want to be able to do that. We want to react quickly. We want to eliminate toil. We don't want to sit there and like just point and click. We want to work on the cool stuff, right? Programs and stuff like that. And most importantly, we want to provide fast delivery of software. I think that's the most important. I think devs agree with that, right? If you guys can deliver your software fast, you're happier, right? It's because you can fix things faster. You can test things out, see if it works or not. It's like because you have the confidence that hey, if it doesn't work, I can roll back really quickly. We want to be able to empower devs to really test things out and take a little bit of risks. You know, it's okay to take a little bit of risk, especially in an industry where we haven't been defined yet, right? And we don't know what's the thing that's going to be built, so we have to take some chances. So the first thing we converged on was Terraform. We decided that we were going to represent our infrastructure as using Terraform. I'm just going to give you just a brief highlight of Terraform. Again, I'm kind of hand wavy, just see a lot of things. If you guys have questions, please interrupt me, or don't throw a bottle at me though. But if you guys do have questions, I haven't stopped yet for questions, but if you do, please interrupt me and then feel free to ask, okay? So Terraform. Terraform, basically you represent your code, your infrastructure as some configuration, right? You say, I want a resource, an AWS instance, I want this AMI, I want this instance type. What Terraform does is take these resources and applies it against AWS. With those resources, it creates a directed graph to say how resources are tied to each other and creates this thing called a state file to say this is the state of your infrastructure. Every time you do apply, your infrastructure state is refreshed based on what it is, and then make sure that what to add changes in the code. So it's a great way to manage it. The most simple Terraform you could probably consider just configuration, but as Terraform gets complex, if you think about it, if you have a way of issuing your instance 8 RFM groups, and there's certain tags you want it, there's certain grammars you want it, you probably wind up creating a reusable module that everybody that uses it will get the same tag, same version, same AMI, and that sort of thing. So you wind up getting into reusable code, get modules. So Terraform code can grow very quickly and can become very unmanageable very quickly. I don't know if anybody's worked with Terraform, but large state files are the worst. So it can get out of hand really quickly and become like a Terraform plan could wind up taking 12-15 minutes when you're just making one simple security group update, right? So that's something to be careful with. So what did we converge on? We did what we call Weedmaps GitOps. GitOps is a term that's going on around right now. You probably have heard it. Basically, we're saying that all our configuration, all our infrastructure, all our operations is going to be represented in Git, and that's going to be the source of truth. Eventually, what we're converging to is that we're going to have nightly runs where Git is going to be source of truth, and whatever is in the infrastructure, it's going to be returned to the original state to whatever is in Git. So our workflow right now, at this point was now a user, they create a branch, they do all their infrastructure changes, they apply it to the test environment, make sure that it works well in the test environment, that sort of thing. Create a PR, pull request. If anybody doesn't know the GitHub flow, pull request. So somebody else can review it. The pull request, because it's tied to Jenkins, the pull request will have a link to the Terraform plan. So the reviewer can look at the Terraform plan to see what's going on, what changes are being made, how many resources are you affecting. Reviewer approves it, gets merged into the mainline, and now we start our pipeline. Mainline, the first thing that happens, our lowest environment gets applied to. Then at this stage, we still didn't want to blindly just apply to environments. Mind you, we're still living new Terraform, so we haven't got so comfortable. We're like, just do what you're doing. So we put an approval process. So I don't know if anybody's worked with Jenkins files or Jenkins workflow. So we just put approval steps in between each environment applied. You approve it, and it goes through. We also have some chef in our code base as well. Some chef, a lot of chef. Chef is sort of our ugly stepchild right now. We haven't been maintaining it as much, and haven't been giving it as much love as it should. But when we came in, we decided we're going to use Chef DK, use the Chef CI patterns. I'm not sure if anybody's seen those, but basically create reusable, create libraries of Chef that get CI automatically. So what happens is you create some Chef code. It runs some what we call test kitchen. So we'll actually apply that Chef code to some virtual machine, make sure it's all right, and then once you're good with that, you'll check it in and then upload to Chef server. And that's all automated. So the one big thing is no ops person should be doing anything from their local environment. Everything should be automated. Jenkins is the tool that's going to be running all five of this. Nobody should be doing that locally. Everything is automated. Git controls everything. Once you check everything in the Git, Git's going to drive the workflow after that. So from anything, people, to be honest with you, a lot of people don't even need Terraform locally, right? It's just like they can do a test and they can just see the plan run in Jenkins, right? They don't even have to run the plan locally. So this is really to eliminate people accidentally doing things from the local machine. We all make mistakes. Mistakes happen, right? If you're not making mistakes, you're not trying, right? So those types of things that happen. All right. So then we go, okay, so how do we handle faster software delivery? So, go ahead.
Real quick, in any of your iterations, have you ever used Terragram or tried to?
I have looked at Terragram. I still haven't seen what I can use it for yet, right? It seems nice, but it still feels like, to me, Terragram still feels like you're writing in enough configuration that you're writing Terraform files as it is. So I still haven't seen the benefit yet of writing Terragram, and maybe missing something. If somebody has an example of using Terragram in an effective way, I would really love to talk to you about it. But I still haven't seen the benefit of it yet. In my mind, that's my experience. So we went from commoditization of infrastructure to now data center as compute. So what does that mean? Docker changed a lot of things, right? But Docker is not new. The concept of Docker has been around ever since Unix has been around. Separating process groups on a Linux server to root. It's basically like, if you think about it, Docker is glorified to root jails, right? And they just created a workflow in defining everything now. So how do you create that? Create just simple configuration files to how to define networking, those types of things. So Docker was a big influence on that. But the Docker only controlled this process space on your instances. How are you going to coordinate just now putting all these different things that require different process spaces out there? So we got container orchestration coming into play. Kubernetes, Mesos. I put Rancher on there because we wound up using Rancher. It wasn't a big player at the time. It was mostly Mesos was the first one that was really out there. Then Kubernetes just took over from Google and just started doing things. And then the cloud platform said, you know what? Don't even run your own Kubernetes instance. We'll just run it for you and just deploy to us, right? I don't know, but if you guys use Heroku, but Heroku is probably one of the original data center compute, right? You didn't have to do much when you want to launch something, launch your application. So that's where we're at. So what we did was we decided to go with Rancher. And one of the reasons we went with Rancher initially, Kubernetes seemed really big to us right now, right? Rancher was approachable because they were based on Docker Compose files. And a lot of developers knew Docker Compose, right? Docker Compose is familiar and that sort of thing. So Rancher kind of helped us do that with their Kyle orchestration tool to kind of get our feet wet with container orchestration, get our feet wet with containers, and understand it without having to learn too much at the beginning. So we decided to go with Rancher. So now what does our software stack, what does our infrastructure kind of stack look like? It looks pretty much the same, but instead of having application instances, these are just Rancher clusters that run Docker containers. So now when we deploy our software, we're not changing out these instances, right? We're just gonna update images on the instances themselves. So each of the Docker images gets updated. We don't have to change out auto-scaling groups and that sort of thing. So software deployment can become faster. Bringing up a Docker image doesn't take that long, depending on how your app developers do the startup. Same sort of every one of our backend services will get master replicas. Our backend services, we put an API gateway. So now backend services, how you talk to them, you register yourself with the API gateway, and every backend service, you have to go through an API gateway. Front-end services, we have a web apex that we use that gets the front-end services, or we have direct load balancer access to the front-end service. Very simple, same thing. There's not much has changed. Our Terraform code probably wouldn't have changed much at all in this instance. We're still bringing up an auto-scaling group and that sort of thing. Go back. It's a little bit about commoditization of infrastructure. What's interesting, like one of the things is that when we went from from rack and stack to commoditization of infrastructure, there's a mindset shift we had to go through. When we had data centers, uptime was valued. Like if you need a computer to have good uptime. Now in commoditization infrastructure, you're working with virtual machines. Virtual machines aren't reliable, right? And they can change. Uptime's not at the utmost important. So if you can build something that you're recycling your instances on a frequent basis, you're guaranteeing your reliability even more, because you're not relying on your virtual machines to run for a longer time. So to me, before when I logged onto a server when it was a rack and stack, and I see the uptime of 300 days, I'm like, wow, that's good. Now if I go into an instance and I see 7 days on an instance, I'm scared. Right? I'm like, why is this instance up for so long? Well, so it's a mindset shift. It's like everything's not meant to be there forever, right? You got creep stitching them out and stuff like that. So that's a very important cultural shift. So what we changed now is our deployment workflow. No more blue-green deployments. Well, we kind of do blue-green deployments. So now what happens is we started adopting this flow called Rep Spectacular. Basically, it's GitHub flow with environment branches. I don't know if anybody's worked with GitHub flow. Anybody not familiar with GitHub flow? Okay, I want to talk about it. So merges to the main line, you build the Docker image on the merge to the main line, and deploy to the lowest environment automatically. Merge to the main line, deploy Docker image, build the Docker image, deploy to the main line. What we then do is, the cool thing about Git is that every commit creates a unique identifier for it. That Git SHA can uniquely identify that commit. So at that point, we use the Git SHA as the identifier, basically the version for our app. And that Git SHA winds up traveling everywhere with the container, the image, and everything like that. So now we know that we deploy that Git SHA. It works well in whatever lower environment. We say, okay, that SHA works well. Let's push it up to the next environment. You do what we call ref specs push. Now we don't rebuild the container. We take that same image and now deploy it to the upper environment. So the same image, so you're not rebuilding the same image, the same artifact is moving up through the environments without any recompilation, rebuilding, or anything like that. So now we have a good, effective way of testing our software in each environment. And that same image you can pull down locally and test it out locally. So now you can run, because if you've done the image right and followed the 12-factor app, all your configuration should be environment variables. So you can pull it down locally, make sure you put the right configuration, you can hit an environment that you need to test against. So you can do your debugging locally as well. So we like that flow. We wound up using Circle CI, so we got rid of Jenkins, wound up using Circle CI to drive it. Jenkins is good. I'm not going to bash Jenkins. It's been true and sturdy for a lot of people. The problem it's went through is it tried to be the golden tool. It tried to do too much. It tried to do everything for everybody, right? You got plugins that don't work with each other and stuff like that. So we wound up with Circle CI, going with that. The developers happen to like it a lot too. So we wind up going with Circle CI, and Circle CI now drives kind of our deployment workflows. So we changed our workflow for Terraform. We did the same sort of thing. Now for our Terraform code, merges to the mainline. We run plans on all environments, and then automatically deploy to the lowest environment. Pushes to environment branch, we automatically run applies to that environment. We are at a point where we can check in something to Terraform and merge it and have everything deployed to production within about 10 minutes. Applying Terraform and everything like that, get our changes up into production within 10 minutes. That's, mind you, I'm not bringing up an RDS instance, right? Because RDS instance itself takes about some while to bring up. But so we're practicing continuous. Now we're practicing continuous deployment with our infrastructure, right? We're gonna wind up using the same build automation tools that the developers are using. So our infrastructure as code is following the same flow that developers are using, right? And so that's a big thing. We're all on the same page. We're using the same tools, same way of working, same way. So there's a familiarity with that. Again. Chef is still the ugly stepchild. We didn't do much. We left it in Jenkins. We're still trying to figure out with Chef, because now that we've got most of our infrastructure on Rancher, Chef doesn't seem to make it as much because we're not maintaining instance configuration as much, right? Because everything's represented in the Docker files, the Docker images. We're just bringing up an instance. We're just bringing up an instance that basically just has Docker on it, right? And so why does Chef fit in that? So we're still trying to figure out where we're going with Chef. It may be just like our core instances or something like that. We use Chef to maintain it. Maybe we just go pure Chef solo and not even have Chef server and just make it to set up instances, you know? So we're still going through with that one. So that was a lot. I'm gonna take a pause. I felt like I talked a lot. I'm kind of out of breath too. Does anybody have any questions? Kind of like anything you want to talk about? Any concerns? Anything confusing? Was I way out there?
What does the development workflow look like for all this? Mini cube or telepresence?
No. So developers locally use Docker Compose, develop locally if they'd like. We're not prescriptive on, hey, locally you have to use Docker. If they like, they can use Docker Compose. A lot of developers develop locally. At the end of the day, if you can define your app with a Docker file and a Docker Compose, we'll deploy it. So what happens after that is then the automation kicks in and just deploys it using, so Rancher has this thing called Rancher Compose. So the same thing as Docker Compose, you do Rancher Compose up and you pass it the Docker Compose file and it'll deploy it to the actual Rancher environment. So developers locally, I'll be honest, most of our developers don't use Docker locally, and that's fine. But to me, it's like whatever gets you to work on your code the fastest, use it. Right? So it's not necessarily, I don't think it's, as long as you can define your app as a Docker file and define like, the other real key thing I think in that case is that I think a lot of times when we build our apps, we try to make it so the apps fail gracefully. I feel like in a containerized environment, you want the container to fail as fast as possible. So if your app does something bad, don't swallow the error, don't swallow the, like, make the container fail. Because what happens is the container orchestration tool is going to restart it and just spin up a new instance. Your container orchestration tools are going to take care of that. So I feel like as an app developer, you're not thinking about building an app on an instance. You're thinking your whole instance as the app, right? And so like entry point. So how do I know how the instance is healthy? That's where my app check should be and those types of things. And that's kind of the mindset shift. Did that answer your question?
Yeah.
Sure. Okay. Any more questions?
Kind of glossed over Chef. Difference between Chef and Terraform?
Chef. Chef is a configuration management tool. So Chef is a DSL, domain-specific language, written in Ruby that basically, so you don't have to write Bash. Basically, so Chef becomes like, if you Chef solo, it's like just nice Ruby DSL to be able to install packages, install they have some Chef. You have some Chef libraries that install, let's say, Apache. So I was once the maintainer of the Apache cookbook for Chef. So you can install Apache and that sort of thing. So they have these reusable cookbooks. The issue I'm starting to see with Chef, I'm having a problem is like around the whole Chef workflow. as you start going further, the dependencies, like, trying to get Test Kitchen working, trying to get all the gems right. Once you get all these little different, like, you get sorry, Ruby guys, gems, and dependency management with gems is just, I'm not a big fan of it.
Says that it's the Go developer. Come on.
We just put everything in the vendor directory. That's all you have to do. Just check it in with the code. It's there. No, but so one of the big things that we wound up on our Jenkins server was that if a Chef Repo had a older gem, like if one Chef Repo was using a certain version of the gem, if somebody went in and installed the gem globally, we get gem conflicts just to run Test Kitchen, just to run Chef Spec and those types of things, and so it becomes like just building the tooling around Chef becomes a lot of headache. It's very unmanageable. So that's kind of what I got with that. Did I explain Chef? So lessons learned. So this is kind of like I did a dry run with some folks at work and stuff like that, kind of getting some feedback and stuff like that. And we started taking notes on kind of like the feedback, and I just decided these are just notes I took during the feedback. I just left them there because they're kind of interesting, right? And see what the ops team thought of like this whole journey, because it's kind of reflective for them because they haven't seen this, they haven't a chance to reflect on this, and they actually seen it, and they're like, one of the things they're saying is adoption is hard. You gotta convince people to make changes. Making change is hard. One of the things, big things I feel like I learned, if you can deliver things fast, you don't have to get it right the first time. You could try something as long as you know what you want to try to get to. You don't necessarily have to get it right the first time. You can eventually converge to what you want to be. That's one of the big things. Again, adoption culture change is hard. We're changing mindsets. We're going from, you understand that whole evolution that happened probably in my entire career in the internet, right? So things changed a lot. Now you're telling people from going onto servers, SSHing in, deploying their software, saying, hey, there's this little virtual thing that's running your software, trust it, right? There's a lot of big culture change that's really hard to do. Mindset, thinking about things differently, like the whole uptime thing. Thinking about like now I want to refresh instances as often as possible. I want things to fail as quick as possible. I want things to fail often so I know things are failing. It's really bad. It's really interesting. Again, we want to make our instances fail. We don't want to make the application fail. We want to say just fail the instance somehow. Especially in Docker, like if we could fail the container or the health check, right? In the Docker world, it'd be just make sure the health check doesn't pass when your container's bad. What's interesting is defensive programming, right? When you're writing for external services, first assumption you make, the network's not going to work. Just assume the network's not going to work and start out working that way. Assume because you're going to be talking to multiple services. You move to service-oriented architectures. There's 10 or 20 services. Just assume they're not going to work and start with that failed scenario. Ensure tooling. There's no one golden tool. You're not going to be able to pay for it, right? People say, oh, let's just pay for it. Like, let's get somebody else to do it. There isn't going to be. At the end of the day, you're going to wind up going through, you're going to have multiple tools, and there's something that's going to have to tie those things together, right? There's going to be tooling that you need to have. And ensure that you can get the tooling in place effectively. And then I guess with that is, I think that's a cooperation then at that point. I believe in a lot of lean philosophies. Like sometimes you're not going to produce the perfect product. There's going to have its flaws, but we iterate to it. So I think in the single organization, if we could work together and just kind of iterate to the solution, sometimes we can deploy tools a little bit early just to get a feel for how they work and those types of things, and we get through it. I know pain happens. I understand pain happens, but we can work through it. ChatOps. ChatOps is big. I didn't cover in it. But ChatOps is big. That's for tooling, right? So you don't want people have to download like 3 or 4 different tools onto their box and learn how to run those things. You have just a chatbot that can do everything for you. Use it. Capabilities and complexities. So I want to touch on this a little bit. What's funny is like we introduced a lot of capabilities to our infrastructure. We're able to do a lot of things now. And sometimes it feels like toil because now that you've introduced all this capability, you have all these things that are maybe breaking. Sometimes they're flaky. Sometimes those are things, but you're working through it. So at the end of the day, the complexity is going to hit you, but if you can start figure out how to manage the complexity, you can make it work, right? Because you are getting very much increased capability, a lot more than when we used to rack and stack servers, right? So you have to be really careful managing complexity, and we've done a good job. We found out that our state files are too large in Terraform. What we decided to do is we said, okay, instead of that, let's make smaller state files and use remote source to manage that. You know, so then you have smaller Terraform plants to run. It's just converging to the right thing. Another thing is, because we're building all these tools, we're building all this automation, and that's the other thing, I don't have time to administer a Postgres database, you know, or build and configure a Postgres database. There's a service, if there's an AWS service for it, use it. Because you're going to be spending a lot of time on automation. You're going to be spending a lot of time on piecing these things together. And if you can leverage somebody else who's actually good at it and they've been doing it, take advantage of it. That's kind of what we've gone through at Weedmaps as a DevOps group. I don't know if I'm just gonna pause real quick. Any questions? Feedback? Anything? All right, cool. So I'm gonna leave you with this. So references. A lot of this was based on Paul Hines. There's a good applying graph theory to Terraform. So he talks about how Terraform works and how he uses graph theory to create this Terraform infrastructure. At the beginning of the talk, he went through this. An evolution of infrastructure. Kind of a short one. It was about 6 minutes. He went through. I thought it was a great framework to kind of give our story. So I heavily borrowed that. I know we all stood on the shoulders of giants. So you know, so I heavily borrowed from that. So that's a great. If you guys ever get a chance, it was a great talk. Please go visit that. A lot of my next slides based on this DevOps Kung Fu. Adam Jacobs, CTO Chef, did this awesome talk a couple years ago at the Chef Conf. He did this talk on DevOps Kung Fu. If you guys ever get a chance to see that video, I highly recommend it. If you want to link to Rep Spectacular, there's the definition of what Rep Spectacular is. If you want to connect with me through the interwebs, at Rock Patel on Twitter and github.com/Rock Patel. So on a final note, I'm going to leave you with this. You can't read that. That sucks. So what this is, the Wikipedia term for Kung Fu. So in China, Kung Fu refers to any studying or learning or practice that requires patience, energy, and time to complete. The original meaning Kung Fu can refer to any discipline or skill achieved through hard work and practice. So it doesn't necessarily refer to martial arts. I like to think of our DevOps journeys as our way of practicing our DevOps Kung Fu. And just kind of reflecting on this thing. We're always trying to practice and get better at our skill. So on that note, I wish you luck in all of your journeys in practicing your Kung Fu.